Hello everyone. Today we will be learning about 8.4 geometric series. What is a geometric series? Before we answer that, we must know what is a geometric sequence. From last time, a geometric sequence is something like this. 8, 16, 32, 64, ... And what's actually happening between each term? You are doing the same thing every time to get the next term. You're multiplying. Yes, that's right. You're multiplying by 2. And 2 is known as your common ratio. Common ratio. Now today we're going to be dealing with geometric series, which is the sum of the terms in a geometric sequence as above here. So instead of these commas separating everything, you're going to have, wait for it, you're going to have plus signs separating each one. Okay, so you're adding all these guys here and so on. Okay, so the sum. Now there are two formulas, and I'm just going to give it to you here. The first one goes like this: Sn equals a times bracket 1 minus r to the power of n bracket over 1 minus r. Mr. G pointed something out to me. I thought, that's pretty clever. Let me use that as well. So suppose I were to factor out a negative from this bracket, like so. Take out a negative 1, this a's, and then just copy everything over. Okay, so a, and then this 1 becomes a negative 1 because I'm taking out, I'm factoring a negative from this. This negative r to the n becomes positive r to the n, and I write it in the front here because it's just prettier that way. In the bottom here, you take out a negative, so this 1 becomes a negative 1, and this r becomes, this negative r becomes positive r. So notice what happens here. There's a negative here, there's a negative here, and they will cancel. So you end up getting this equation here. Sn equals a times r to the power of n minus 1 brackets over r minus 1. So I'm going to call this equation 1. That's probably a little bit better than this one that I'm used to up here, because I can just see problems when people are plugging in r and then getting confused with the negative, and then it's just, you kind of avoid all that stuff if you put the r in the front here like this, like so. So you could use this formula here. I think that's fairly clever. So thank you, Mr. G. And the second equation goes like this: Sn equals a minus rl over 1 minus r. Okay, so that's the second equation, and that's what we're going to use as well sometimes. Now, I must say one thing here. Notice that we've got, a rational expression where you've got denominator, right? So you cannot have a number, specific number for r. And I'm going to tell you what that is. You cannot have r cannot be equal to 1. Why is that? Well, if r is 1, we plug it in there, 1 here or 1 here, then you get 1 minus 1, or, well, in both cases 1 minus 1, so 0 on the bottom of a denominator, which means you're dividing by 0, which means this whole thing blows up to undefined, or really, theoretically infinity. But so we can't have that, so we're just gonna make a restriction there. So make sure your r cannot be 1. Okay, so if you get something like r equals 1, then I suppose there is no solution. Now, what is r equal to? What is a? What is l? R is equal to common ratio. Common ratio. What you're multiplying to get the next term, and so on. Okay, a is equal to the first term. Okay, and L, you have a nice cursive L, is your last term. And let me just qualify that, because last time I did a video, I said, your Tn is usually your last term, and I'm going to just be more specific here. If I asked you to find S7, the sum of the first 7 terms of anything, either an arithmetic or geometric series, then your last term must be equal to T7. Okay, last term must be equal to T7. If I asked you to find the sum of the first 100 terms, then your last number has to be T100. But suppose I asked you to find S55 and I give you T40. Well, T40 is not your last term. And I'm going to put this in red. Like this, okay? Ooh, that doesn't look good. No, not equal to. So notice here your ends must match. Okay, the ends must match in order for your Tn to be your last term. Just remember that. And I'm gonna put this in blue because this is, they don't match. They don't match. Different colors. They don't match. Okay, moving along now. Determine the sum of the first 10 terms in 4 plus 12 plus 36 plus dot dot dot. So let's identify some things here. This here is my n. This here is my a, my first term. This here, oh, no more things to highlight. Going from 4 to 12 to 36, what am I actually doing? You are multiplying by 3. Multiply by 3, multiply by 3. So our ratio is equal to 3, common ratio. Okay, so let's write all this information on the side. N equals 10, A equals to 4, and R equals to 3. So the question is, what is S of 10? Question mark. Well, let's look at our formulas here. I have N, A, and R. So let's see if we have enough information to plug everything in. N, A, R, R. Oh, hey, look, let's use the first one because that's sufficient. So that's what I'm going to use. Sn equals A, R to the N minus 1 all over R minus 1. Okay, so S, what was it? We are figuring out S10. So for every N that you see, you will plug in 10. A is equal to 4. R is equal to 3. N is equal to 10 minus 1, like this. And our ratio is 3, and then minus 1. Okay. Now, I didn't put brackets around my 3 because it's positive. If it was a negative ratio, I would put brackets around that. So just be careful. Now, remember to abide by the laws of BEDMAS. BEDMAS, okay? So you need to do everything inside these brackets first. So 3 to the power of 10 minus 1, and then times by 4, and then divided by essentially 2 on the bottom. 3 minus 7, which is 2. And you should get 118,096. Oops, let's do that. Yeah, 118,096. Okay, so the sum of the first 10 terms in this geometric series is 118,096. Okay, let's move along. Oh, I didn't tell you to pause. Darn. Let's do it here. Determine the sum of this series here, this geometric series. Why don't you go ahead and pause now? Please pause and try this yourself. Please pause. Please pause. No? No pause? Okay, well, let's just go on. We can't do this all day. Here, this thing is our first term. Is our A. This one here, this nice juicy number, is our last term. L. Our ratio, sometimes I can't do the mental math because I'm elemental, so I'm going to figure this out myself. Okay. You'll have to figure this out. I take any two terms side by side, successive term, take the second one over the first one, or the third one over the second one, which it's easier for me to do the third one divided by the second one, so the ratio is equal to 1/3 divided by 1/9, which is equal to 1/3 times reciprocal of 9/1. And there's some beautiful cancellation here. This is 1, this is 3, and guess what? R is equal to 3. Okay, so let's write out information. A is equal to 1/27. R is equal to 3. L is equal to 729. And we are trying to find S. Do we know N? We don't know how many terms that is, so Sn. So suppose you could find out N if you wanted to. Let's see if it's necessary, because you know what? It might not be necessary. So I've got ARL. Oh look, there's an N. I need to find out N, so I can't use this formula. Let's go to the second one. ARL. I have L's, I mean, and I have R as well. So I don't really need to find out N. So let's just use the second formula. Shall we? We shall. So Sn equals A minus RL over 1 minus R, which is equal to A is 1/27. Oops, I need to use different color when I'm plugging things in. 1/27 minus ratio, which is 3, times the last term, which is 729, all over 1 minus 3. Okay. And let's see, what is this all equal to? So don't forget to follow up the rules of BEDMAS. You're going to multiply out 3 times 729 first, and then do 1 over 27 minus that product, and then divide by essentially what is -2 here. So you will get, I guess on the numerator, I'll just show a bit more steps here, a few more steps. So -59048 over 27. Okay, that's the numerator, and on the denominator you get -2. And punch this further in your calculator, you get positive, I mean, 29,524 over 27. Now notice your answer is a rational number. It's a fraction. And sometimes students say to me, "But Miss Yang, how can this be?" And I say, "Are you discriminating against fractions? That's not very nice." Because you can possibly, very possibly, have answers that are not integers. So as long as you follow the steps right, then you're fine. Then don't worry about it. Don't worry. Be happy, as they say, as the old cliche goes. Okay, let's move along. Example 3. If a person received a 5% salary increase each year and earned a total of $248,653.41 by the end of the 5th year, determine the starting salary. Okay, let's identify some things here. Okay, let's kind of start off with an illustration. So suppose we had our first term, I guess that's what we're trying to find, the starting salary. So this is A, right? We're trying to find A. This is A. So we start off with A like this. And more space for sure. Okay, so we start with A. And so let's say, for example, that, you know, we had $100, just to keep the numbers small. Now, you receive a 5% salary increase, so that means the next year you're going to get not $5, you can get $5 more, which is 105. And so what are we doing? What are we multiplying to get to the next term? Now, to go from here to here, we're actually multiplying by 1.05. Okay, so we do the same thing here. Times by 1.05 to get the next term. So it's actually 1.05a. And then the next term, I suppose I should put a plus between these guys. The next time, you're just going to multiply again by 1.05. So our next term would be 1.05 squared times a. And then, you know, it's going to be 1.05 cubed a, and then 1.05 to the power 4 times a, like this. Okay, so those are the 5 years, and the total, when you add this all up, they're telling you is equal to a whopping sum of $248,653.41. Okay, so this is what it's telling you, and you're trying to find A. Okay, so there, I mean, these numbers are small enough that I suppose you can get away with not using a formula, but I wouldn't recommend that because if your teacher, I should say, gave you something where n was much higher than 5, let's say it was 27, then it's a bit of a pain to calculate all of this. You know, punch this all into your calculator. Okay, but so we're gonna use a formula to figure out the sum on the left-hand side. So let's identify what we've got. We've got our here. We've got this here. Let me do this. This is, what's that? This is actually S something. This is S. What's their n? N is 5. So the sum of the first 5 terms is this massive amount here. So that's S5, right? We've got S5, and then this here, that's obviously our, what is it? That is our, oh yeah, that's our n. N. And this here, this 5% is not really anything, kind of, sort of, but our ratio is equal to 1.05. So you've got to be careful. So I've got R, I've got S5, I've got N. I'm trying to find A. So let's list this all out and see which formula is best for this. Let's erase all this junk here. It's here. Okay. So I've got n equals 5. I've got S5 equals, 248,653 and 41. And I've got R is equal to 1.05. That's all I have, I think, right? 1, 2, 3. And we're trying to find A. Okay, let's see if we can use a formula here to plug it in based on what we've got. So I've got N, S5, and R. So this here, so this would be, I've got this, I don't have A, I've got R, and I've got N. So I can use the first equation. So let's use the first equation. Shall we? We shall. Would you like to try this? Please go ahead and pause. And I'm gonna start. In case you didn't pause. Sn is, I don't remember that formula. A times R to the N minus 1 over R minus 1. And I've got, let's plug this in. S5 equals A, which is, I don't know. R is 1.05. N is 5 minus 1 over 1.05 minus 1. And S5 I know is 248,653 and 41 cents. Equals all this stuff here. So let's just simplify it a little bit. I'm going to leave the top as that because it's probably going to be a long decimal, so I will just simplify this down here. Okay, well, we're solving for A, so you must isolate A. So I think the next logical thing is to multiply both sides by 0.05 to get rid of your denominator. So let's do that. And insert more space because it's getting squishy here, a little bit claustrophobic. Okay, multiply both sides by 0.05, and what do we get? We get something like this. 12,432 and 674. Remember not to round anything until the very end, and then you get 1.05 to the power 5 minus 1. I don't know why I'm whispering. I suppose it's nice to conserve energy. Okay, and then let's multiply. I don't know what to multiply. Let's divide both sides by 1.05 power 5 minus 1. So on the right hand side it cancels out, and the left hand side you gotta divide by all that, and you end up with A is equal to 4, 5. Oh shucks, I must do this by myself as well. Okay, so I get 45,000. 0.1335. Now remember, because we're dealing with money and salary, this is actually in dollars. 45,000, 3 zeros, and 1 cent. Just because. Must be a very superb employee to get that extra 1 cent. So $45,000 and 1 cent was the starting salary. Alright, our last example. We're almost done here. Thanks for hanging in, everybody. A tennis ball bounces to 40% of its height. Total vertical distance is made from up and down bounce of a ball. The ball is dropped from 20 meters. Draw a diagram to represent 6 bounces. I love these ones because you can draw a little bit here. Okay, so let's draw a tennis ball, I guess. It's a tennis ball, isn't it? And so it initially starts off up here. Yes. Okay, so it starts right there, and it's at a height of 20 meters. Then it goes like this. Ding. Goes up 40%. Ding. 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 Oops, let's try to keep track of everything here. It's 20 meters here. And it goes like this. Doing. So this is this is one bounce. Doing. Second bounce. Doing. Third bounce, doing. Fourth bounce, doing. Fifth bounce, and we gotta have one more, doing. Sixth bounce. Okay, so let's extend this here. I don't know, my diagram isn't really drawn to scale at all. So, yeah. Okay, so that's the 6th bounce, and it looks like our ball is just jumping up and higher from right to left. So I suppose I should erase this here and draw the ball over here. Let's be realistic, Miss Yang. Okay, there. Happy? Okay, so that's kind of the picture of what's going on. It's definitely not to scale, but let me just go over something here. Notice here it says that the tennis ball bounces to 40% of its height. So what it means is initially it dropped at 20, and then it goes up. Well, it only goes up to 40% of its height. So you have to go 20 times 0.4 to get 8. So the first initial bounce is 20, and then this height on the second one is 8. And then to get the next one, times that by 0.4, and you get 3.2. So this one is 3.2, and so on. Okay. Now, one way that teachers can make this a little bit more difficult, is to say that if I told you that the ball loses 40% of its height, that means it's actually going up to 60% of its height, which is going to be your ratio, or really I should say 0.6 is your ratio. Okay, so be careful when you know, I'm probably going to do something like that, but if you know, I want to make it a more difficult test, I would do that. So watch out for things like that. You have to be very careful not to just plug everything away. Okay, so there's a picture, and the question is, what is the total vertical distance traveled when it hits the floor for the 6th time? So this is what they're really asking for. They're asking for what is, so the total vertical distance, right? So like this is 20 plus 8, and then it comes back down, plus 8 plus 3.2 plus 3.2. I'm talking about the vertical distance here, so this is why I'm drawing straight vertical lines, plus whatever this is, twice, plus this, and it's like that. Okay, so that's what is really asking for. And there are a couple of ways of doing this, and I'm going to, well, I'm not supposed to show you both ways. It's getting a bit of a long lesson, so well, that was not my intention, by the way. So what I could do is, I can do it like this. Either we go to, like, find the vertical distance of all these bounces here, so 20. We can go 2 times, you know, 20 plus 8 plus 3.2 plus ... whatever the last one is. Okay, so that would give you basically this 20 twice. I don't want 20 twice because it only was dropped at 20 once, so I'm going to subtract 20 at the end. So you can do this, which is really 2 times, you know, how many terms is that? This would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, I'm losing it here. I'm losing it. Okay, got it. Okay, this is what I really mean. So 2 times all of this, which is basically this is the visual. I'm counting 20 twice, like this, and then subtracting 20. And in this case, you have to be careful what n is. Now n this will be 1, 2, 3, 4, 5, 6, 7. So in this case, this is 2 times the sum of the 7 terms minus 20. So that is going to be one answer. That's one possible way of doing it. The other way of doing it is not counting it twice. So let me just pause here for a sec. Okay, welcome back. So the other way of doing this is to count this part twice, these starting from 8. So basically 8 plus 8 plus 3.2 plus 3.2, so timesing everything by 2 inside here, and then adding 20 because of the initial bounce. So either way works fine, and this one ends up being 2 times S6. There are 6 terms, and then plus 20. So let me just highlight these two. These are going to be equivalent, these answers here, 2 times S7 minus 20, or 2 times S6 plus 20. Okay, so I'm going to do it both ways. Let's go ahead and get started. So the answer, which is basically 2, what is S7 equal to? Oh wow, let's just try to get myself organized here. Okay, so here, let's just figure out what S7 is. So remember, our N is 7 in this case, our A is 20, what else? R is equal to 0.4, and I think I have enough information. So using my formula, I have N, A, and R. N, A, R. So I can use the first formula. So let's go ahead and do that. So A is, I'm just going to plug it right in. 20, and then, what was the formula? R, so 0.4 to the power of 7 minus 1 over 0.4 minus 1. Okay, you do all this math, fed mass and all that, you get 33.27872. Okay, and then so now the actual answer is 2 times S7 minus 20, so 2 times 333.27872 minus 20, and your answer is 46, let's do it to 2 decimals, 46 and 56 hundredths of a meter. So that's the total. Oops, doesn't want to do that. Okay, and now let's try it the other way. And if you understand this all, you can, I suppose you can stop now. But if you want to see the other way, let's. Okay, this other method is the only difference here. You have to be careful. Your A is equal to 8 because you're starting off with 8, and then you're gonna add 20 at the end. Or, and also, sorry, I should say N is equal to 6. There are only 6 terms here. So S6 is equal to this A, which is 8 per 8, 0.4 to the power of 6 minus 1 over 0.4 minus 1. And in this case, you will get 13.27872. And then our answer is actually equal to 2 times S6 plus 20, which is 2 times 13.27872 plus 20, and then rounded to 2 decimal places, you get the same answer as well, 46.56 meters. And there you have it. Thanks for slugging through.